Graph the solution set of the system of inequalities. Our inequalities are 2x plus 7y is less than or equal to 14, and x minus y is greater than or equal to 1. So our solution to this system is going to be a region in our xy plane. Let's begin to determine that region by first graphing the boundary line for the inequality 2x plus 7y is less than or equal to 14. So we're going to begin by graphing the line 2x plus 7y is equal to 14. I'm going to do this by using an xy t-table and plotting intercepts. If we let x equal 0, then y is equal to 2. If we let y equal 0, then x is equal to 7. So as we graph this line, we're going to graph it as a solid line because our inequality does include the equal sign. So we'll include points on the line. This line goes through the point 0, 2 on the y-axis and the point 7, 0 on the x-axis. So 1, 2, 3, 4, 5, 6, 7. Out on the x-axis, we're going to graph that as a solid boundary line. And now let's decide which side of this line to shade. Let's choose the origin as a test point. So let's test the point 0, 0. In our original inequality, 2x plus 7y is less than or equal to 14. If we substitute 0 for x and 0 for y, we'll get a cumulative 0 on the left-hand side. And 0 is indeed less than or equal to 14. That statement is true. Therefore, the solution region for this inequality includes the point 0, 0, and we shade below the line. Next, let's graph our second inequality. X minus y is greater than or equal to 1, and we'll graph its boundary line. X minus y is equal to 1 using a t-table as well and finding our intercepts. In this equation, if we let x equal 0, then negative y is 1, or y is equal to negative 1. If we let y equal 0, then x is equal to positive 1. Again, we're going to graph this boundary line as a solid line because the inequality has the equal to part in its symbol. So this boundary line goes through the point x equals 0, y equal negative 1, and the point 1, 0 on the x-axis. We'll graph that as a solid line. And let's determine which side of this boundary line to shade. Again, we can test the origin because it's clearly off of that line. So let's, again, test the point that is the origin at 0, 0. In the inequality statement, x minus y is greater than or equal to 1. If we substitute 0 for x and 0 for y, we'll get 0 on the left-hand side. And is 0 greater than or equal to 1? No, that is not true. That is a false statement. Therefore, the origin is not included in the solution region for our second inequality, which means that we do indeed shade the other side of that line. Now, for our solution to our entire system of inequalities, that solution is this intersecting region that is a solution for both inequalities. So our solution, I'm just going to bold this a little bit more, is this region that is down below both of the lines. So we have indeed graphed the system of inequalities. 2x plus 7y is less than or equal to 14, and x minus y is greater than or equal to 1.